proving trig identities. And trig identities they sometimes look like equations, but really they're identities. What we want to show is that this left-hand expression is equivalent to the right-hand expression. And we show that by showing algebraic steps to prove that one side looks the same as the other. Okay? So these are identities. So these have to be true. So this left side has to be the same as the right side. And our goal is to show that they're the same. Okay? And we do that with algebraic manipulations. So I'm going to do some examples here. One thing that I want to note here is that when we can check left side and right side, graph the left side expression and graph the right side expression, and we can show that they're the same if they graph right on top of each other. That means those two expressions are the same for all values of theta. Okay, and that's what an identity is. Identities are true expressions that are equal for all values of theta, as opposed to equations where they're true only for specific values of theta. Okay, and we can actually solve for those. These ones we don't solve. We're just going to show that they're true, that the relationships are true. Okay, so I'm going to give you guys an example here. So the first example here is showing that this expression 1 minus cos squared is always the same as cos squared minus tan squared. Okay, we can show this by stating or changing these expressions to make them look like the other. And when we do that, when we're proving this and doing the algebraic proof, we can change the left side, we can change the right side, we can change both, okay, as long as at the end the left side statement looks the same as the right side statement. So we kind of do it in a kind of left side, right side manner. So what I can do is I can look at these expressions and convert one expression into another. So 1 minus cos squared, if you look at your formula sheet, is one of the Pythagorean identities. Okay, and that's another key as well. Make sure you have a formula sheet next to you when you're doing these. That way you get used to the formulas and you get familiar with them. You'll be able to recall them much quicker. But to start, you need to have that formula sheet with you. Okay, and when we do, when we're doing these problems, we should always have that formula sheet with us. Okay, otherwise we spend a lot of time just kind of guessing, and that's not a good way to be doing these problems. Okay, so the left side here, looks like the Pythagorean identity, and I can convert that to sine squared. Okay, so that expression is equivalent to sine squared. This one here, I'm going to work on the right side as well. And I know that tan can be replaced with sine squared over cos squared. And I can see that algebraically these will cancel out, and I can show that the left side, sine squared theta, is equal to the right side, sine squared theta. That is an algebraic proof. Okay, and we don't want to skip too many steps. We want to show the process of how we can make these algebraic conversions from this expression to this expression, okay, this expression to this expression to this expression. Okay, and that is a proof. And we have to be able to follow that proof, otherwise it's not a good proof. Okay, so here's the second one here. That's the one that we're given up here. This expression 1 plus sine theta divided by cos is always equal to secant theta plus tan theta. Okay, so one of the things that we don't always have to do this, but we should look at what are the non-permissible values. So I should state the non-permissible values. I'm going to state them in terms of the trig function. So cosine theta cannot equal 0. Okay, here cosine theta cannot equal 0 as well. Here cosine theta cannot equal 0 as well. So those are non-permissible values. Now, in more kind of advanced courses, and some in pre-calc 12 too, but I'm not going to require this, you would sometimes be required to solve for theta. So in this case, theta is equal to 0 at 90 degrees, or pi over 2 at 3 pi over 2, and so we're going to generalize that to pi over 2 plus n pi. Okay, so every every 180 degrees, it's cosine theta is going to hit 0. Okay, so what's the proof look like? So again, I want to show algebraic steps to show the right side and left side are equivalent. This time I'm just going to work on the left-hand side. I'm just going to algebraically manipulate these by splitting this up. I'm going to write this as 1 over cos theta plus sine theta over cos theta. Okay, there's my left side, right side. 1 over cos is equivalent to secant theta. Sine theta over cos theta is equal to tan theta. And now I have my left side equals right side. There's my algebraic proof.